Welcome to Study Loop.
So we're gonna use Gauss's law. We're gonna say that the electric field times vector times the area vector would be equaling the enclosed charge divided by epsilon naught. As a Gaussian surface using a radius r on a given sphere, we have that here E equaling E multiplied by 4 pi r squared. This would be equaling the enclosed charge divided by epsilon naught. And so we can then say that the electric field would be equaling 1 over 4 pi epsilon naught multiplied by the enclosed charge divided by r squared. This would be essentially equal to k times the enclosed charge divided by r squared. And then in each case, we need to the enclosed charge, given that the enclosed charge is equaling the density times the volume, the charge density times the volume. And then we use that result to calculate the electric field. So we can say for part I, we have that the enclosed charge is equaling the charge density of 10.0 times 10 to the negative 6th coulombs per cubic meter multiplied by 4 pi over 3 multiplied by the radius of 0.00100 meters quantity cubed. This is equaling 4.19 times 10 to the negative 14th coulombs. And so we can say that the electric field would be equaling K 8.99 times 10 to the 9th newtons meter squared per coulomb squared, multiplied by essentially the enclosed charge 4.19 times 10 to the negative 14th coulombs, all divided by 0.00100 meters quantity squared, and this is giving us 377 newtons per coulomb. This would be our answer for part I, or part 1, part 2. We have that the enclosed charge here is equaling, again, 10.0 times 10 to the negative 6th. This would be, again, the charge density coulombs per cubic meter multiplied by 4 pi over 3 multiplied by 0.00200 meters quantity cubed. And then it would be plus 4.0 times 10 to the negative 6th coulombs per cubic meter multiplied by 4 pi over 3. And then this would be multiplied by 0.00300 meters quantity cubed minus 0.00200 meters quantity cubed. And we find that the enclosed charge is equaling 6.534 times 10 to the negative 13th coulombs. And then to find the electric field, this would be, again, 8.99 times 10 to the 9th newtons meters squared per coulomb squared. This would be multiplied by the enclosed charge, 0.534 times 10 to the negative 13th coulombs. And then this would be divided by 0.00300 meters quantity squared. And we find that the electric field for part 2 is 653 newtons per coulomb. Now for my apologies. For part 3. We say that here the enclosed charge is equaling 10.0 times 10 to the negative 6 coulombs per cubic meter multiplied by 4 pi over 3 times 0.00200 meters cubed, and then plus again 4.0 times 10 to the negative 6 coulombs per cubic meter multiplied by 4 pi over 3 multiplied by here 0.00400 meters quantity cubed minus 0.00200 meters quantity cubed. And we find that here the charge density, my apologies, we would also add terms here, minus 2.0 times 10 to the negative 6 coulombs per cubic meter multiplied by, again, 4 pi over 3. And this would be multiplied by 0.00500 meters quantity cubed minus 0.00400 meters quantity cubed. And we find that then finally the enclosed charge is equaling 7.624 times 10 to the negative 13th coulombs. And to find the electric field, let's get a new line actually. This would be equal to 8.99 times 10 to the 9th newtons meter squared per coulomb squared multiplied by 7.624 times 10 to the negative 13th coulombs divided by 0.00500 meters quantity squared rather. And this is equaling 274 newtons per coulomb. This would be our answer for part 3. And then finally, for part 4, the enclosed charge here is going to be equaling 7.624 times 10 to the negative 13th coulombs. So from part 3, plus negative 2.0 times 10 to the negative 6th coulombs per cubic meter. This would be times 4 pi over 3, and then multiplied by 0.0600 meters quantity cubed minus 0.00500 meters quantity cubed. And we find that the enclosed charge is equaling 0. Therefore, the electric field is also going to be 0 newtons per coulomb for part 4. That is the end of the solution. Thank you for watching.